Alright, in this video we're going to take a look at evaluating limits involving radicals. So when working with radicals, what we're going to look at is we're going to multiply by the conjugate of the radical. So for instance, if we have an expression such as a plus the square root of b, the conjugate is a minus the square root of b, and vice versa. If we have a minus the square root of b, it's a plus the square root of b. So in essence, the conjugate of any binomial is just switch the plus to the minus and you'll get its conjugate. So what happens when we multiply an expression by its conjugate is it will eliminate the radicals, as we'll see in a few examples. So example 3, we have the limit as x approaches 0 of the square root of 25 minus x and then minus 5 all over x. If we try direct evaluation, we'll get 5 minus 5, which is 0 over 0, and that's no good. So we're going to multiply both the numerator and denominator by the conjugate of the numerator. So the conjugate of the numerator is going to switch this minus 5 to a plus. So we'll multiply both numerator and denominator by the square root of 25 minus x plus 5. Notice the expression inside the square root didn't change. So multiplying square root of 25 minus x minus 5 times the square root of 25 minus x plus 5, the square roots, when we multiply them, we'll just get 25 minus x, and then 5 times the square root of 25 minus x, and then minus 5 times the square root of 25 minus x. Those square roots disappear. They cancel each other out. So that's the benefit of multiplying by the conjugate. And then negative 5 times positive 5 is negative 25. And in the denominator, rather than distribute the x to both terms, we're going to leave it in its factored form, much like we did in the last video with complex fractions. So when we simplify our numerator, 25 minus x minus 25 gives us negative x. And now we have this negative x over x, which is why we didn't distribute it to both terms in the denominator at this step. So negative x over x simplifies to negative 1. So now we have the limit as x approaches 0 of negative 1 over the square root of 25 minus x plus 5. Now if we look at direct evaluation, square root of 25 minus 0 plus 5 doesn't give us any problems, and we end up with 5 plus 5 in the denominator, which is 10. So our limit is negative 1/10. Part B, square root of 16 plus h minus 4 all over h. Again, if we try direct evaluation with h is 0, we're going to get 0 in the numerator, 0 in the denominator. So in this problem, we're going to multiply by the conjugate of the numerator, which is square root of 16 plus h plus 4. And if we multiply the numerator, we got to multiply the denominator. So multiplying the numerator, when those square roots terms cancel out, we're going to be left with 16 plus h, and then negative 4 times positive 4 is negative 16. Again, your middle terms cancel each other out. And much like in the last example, we're not going to distribute the h to both terms, we'll just leave it in its factored form. So in our numerator, we have 16 plus h minus 16. The 16 minus 16 simplifies to 0, so we just have h over h times square root of 16 plus h plus 4. Now h over h simplifies to 1, so much like the last one simplified to negative 1, this one will simplify to positive 1, and now if we use direct evaluation, put in h as 0, we get this 1 over the square root of 16 plus 0, and then plus 4, which gives us 1/8 as our limit. All right, example 3, we have 4 minus x over the square root of x minus 2. We're going to evaluate the limit as x approaches 4. Again, if we plug the value of 4 in directly, we get 0 in the numerator, 0 in the denominator. So we're going to multiply the numerator and denominator by the conjugate of the denominator. So the conjugate of the square root of x minus 2 is the square root of x plus 2. And much like we did with example 3a and 3b, we're not going to multiply out the 4 minus x times square root of x plus 2. We're going to leave it in its factored form. But the denominator we will multiply square root of x minus 2 times square root of x plus 2 will give us x minus 4. So we have the limit as x approaches 4 of 4 minus x times square root of x plus 2 all over x minus 4. And in the last video, we saw what happens when we switch the order of subtracting terms and divide. 4 minus x over x minus 4 will always simplify to negative 1. So we have the limit as x approaches 4 of -1 times the square root of x plus 2. Now if we plug a 4 in for x, we'll get -1 times the square root of 4 plus 2. Square root of 4 is 2. So -1 times 2 plus 2 is -4 as our limit. Finally, example D, we have the limit as x approaches 3 of x minus 3 over the square root of x minus the square root of 3. And if we directly evaluate this at x equals 3, we get 0 in the numerator, 0 in the denominator, and that's no good. So we'll multiply by the conjugate of the denominator. So square root of x plus 3, or square root of x plus the square root of 3, rather. Much like the last example, we are going to leave the numerator in its factored form. Essentially, we want to cancel out radicals. So if you're wondering why we sometimes leave the numerator and sometimes leave the denominator in their factored form, we really want to deal with the part of the fraction that has more radicals we want to get rid of, in this case the denominator. So multiplying our denominators, we get just x minus 3, and leaving the numerator in factored form, we get x minus 3 times the square root of x plus the square root of 3. We have x minus 3 in the numerator as a factor, x minus 3 in the denominator, so divide those out to 1. So we have the limit as x approaches 3 of the square root of x plus square root of 3. Now if we do direct evaluation, we'll get the square root of 3 plus the square root of 3, which gives us 2 square root of 3, or about 3.5. Alright, that about does it for this video. In the next video, we're going to take a look at limits involving absolute value. So I'll see you.